Okay, so this is the second set of notes in Unit 2. Today we're going to specifically take on the idea of reflections. Okay, so a reflection is a type of transformation, and in fact the result is that it's also an isometry, but we'll take a look at that a little bit later on. In order to understand what a reflection is, we got to establish a few terms. Perpendicular lines is something that we're going to be talking about here. So this is not entirely a new concept, but if I have a line and I have another line that makes a right angle, these are what we're going to call perpendicular lines. We're also going to talk about a thing called a perpendicular bisector. It's a perpendicular bisector. So if I have, let's say I'm going to do this up here, okay? If I have some segment, so now one of these is a segment AB, and this point here, we'll call it M, is the midpoint of that segment. If a line or another segment or array, so let's call this line M, sure. Let's call that line P, because that's confusing to call it line M when I have a point M. Alright, so if that line P goes through the midpoint of the segment, and it's perpendicular to the segment, so it's got to be both, going through the midpoint and perpendicular, if that's the case, then we call it a perpendicular bisector. It's perpendicular, and it bisects. It cuts the segment into two equal parts. Okay, so these are terms that we're going to use to talk about reflections. The idea of perpendicular lines, and then, in turn, a perpendicular bisector. Okay, so then what is a reflection? Okay, so what I need is I need a line. We're going to call this line M, okay? And what happens here is if I have some point, I call it P, and I create, through a transformation, another point, P prime, so that if I connect these 2 points, lo and behold, that segment is bisected. So this point here is the midpoint of the segment and perpendicular to M. So M is the line of reflection. And it is the perpendicular bisector of the segment formed by the preimage and the image of a transformation. So if the transformation does this, then I have a reflection. All right, so let's look at this like more clearly with a kind of a better figure. Okay, so I'm going to start with, again, a line of reflection. We'll call it M again. Okay, so over here, I'm going to build a triangle. Let's call this triangle. Oop, that one didn't work. There we go. Ugly. There we go. Let's call this triangle A, B, C. Now, I'm going to try to reflect this triangle over this line. So A is going to end up there, B is going to end up here, C is going to end up over here. So when I reflect it over the line, I get another triangle on the other side, but it's just like a mirror image. Call it A prime, B prime, C prime. So this is a transformation. It's moved A to A prime, B to B prime, and C to C prime. So what's going on here? Well, if I pick a pair, let's say I take the 2 B primes, it's a reflection because this is the midpoint of that segment and it's perpendicular. I can play the same game with A. It's in the middle and it's perpendicular. I can also play hopefully the same game with C. It's in the middle and it's perpendicular. So if I can pick any point here in the pre-image and its corresponding point in the image and connect them in such a way that the line that we call our line of reflection becomes the perpendicular bisector of that segment, then this is a reflection. Woot. Okay. So, key ideas that we have here. Perpendicular lines are lines that form a right angle. How about I actually make perpendicular lines? Alright. How about this? Lines. Craziness. There we go. Lines that form a right angle are perpendicular. If I have a segment that is bisected by a line that's perpendicular to it, this is a perpendicular bisector. A reflection is a transformation that has a line, we call it M, and it takes some point, let's call it P, brings it across that line, call it P prime, and we connect them in such a way that the segment that connects those 2 points is the line of reflection is a perpendicular bisector to that segment. Okay, so if that's the case, then P is the pre-image and P prime is the image of a reflection.